Okay, so here I have a question which says that a line parallel to 2x plus 3y equals 6 passes through a point 2, negative 1, and it should say intercepts, plural there, intercepts the y-axis at C, at some point C. So when they say that letter right there, that's a point. What do they want to know? Well, they want to know what is the equation of this line and what are the coordinates of C. In other words, where does it cross the y-axis? So to get a sense of this problem, let's just make a sketch of it. So I'll set up my y-axis. Well, let me choose a different color. We have our y-axis, and we'll set up our x-axis. Okay. So what do we know? Well, we know that there's a line already. They give us that line. It's 2x plus 3y equals 6. And we know that wherever this line is, it's parallel to that. When two lines are parallel, they have the same slope. So we need to know what the slope of this line is because it's parallel to the slope of the line we're trying to find. In other words, they have the same slope. So let's find that. So they give us 2x plus 3y equals 6. I like to use the format, the slope-intercept format, y equals mx plus b, because this tells us right away m, what's the slope, and b, what's the y-intercept, which in this case, of course, I don't know why would they label it as c. They want to know what that is. So let's get to work. In other words, if we rewrite this in this form, we can quickly read what the slope is. So how do I do that? Well, notice y is all by itself over here, but y is not alone in this equation. So I'm going to solve this in terms of y. I want it to say y equals something times x plus b. So I subtract 2x from both sides, and what do I get? Well, I get one step closer because this cancels out. And now I have 3y equals 6 minus 2x. I don't want to know what 3y is, I want to know what y is, right? Because this form here has y equals mx plus b. So I divide everything by 3. This cancels out. Right? 3 divided by 3 is 1. 6 divided by 3 is 2. And 2 divided by 3 is 2/3. Actually, let me write it like this. That was sloppy on my part. So now 3y divided by 3 is 1y. 6 divided by 3 is 2. And 2 divided by 3, or 2x divided by 3 is 2/3 x. Right? 2 divided by 3 is the same thing as 2/3. I'm going to switch this order around. So it says y equals negative 2/3 x plus 2, right? Those are equivalent to each other. Same exact thing, I'm just changing the order. And now I know what the slope is of the line, right? In this line, the slope has to equal what? Well, it says negative 2/3, right? That's the slope of this line, and they're both parallel. They have the same slope. So let's just take a look at what this means so far. We know that our line passes through the point 2, negative 1, which is right here. This is 2, negative 1. And we know that this line, we just calculated this over here, has a slope of negative 2/3. And it has a y-intercept, it tells you, of 2. So that means it passes the y-axis at 0, 2. So if we graph this line, the one they give us, on the graph, we can get a sense of what they're asking. So let's say the y-intercept's here, which it is, right, 0, 2. And the slope is negative 2/3. What does that mean? Well, the top number refers to the change in y, and the bottom number refers to the change in x. So negative 2 means if we start at this point and we follow the slope, we go down 2 and then 3 over in the positive direction on the x-axis. 1, 2, 3. Right? So this line, and we'll do that again, right, down 2 and over 3. So 1, 2, 1, 2, 3, right here. And we have this line. This is what they give us. So we're basically trying to find a line that's parallel to it and passes this point here. So you can imagine that this line, just by estimating, right, is something like this. Oops. Right? It will look the same. And in fact, we can get really close if we just use the slope to figure this out. Because the slope will do what? It'll have the same effect. So instead of going the way we just did, well, we can do that. Go down 2 over 3. It's a point here. We can go in the reverse direction. So up 2 and over 3. So up 2 and then over 1, 2, 3. So we can see intuitively that these things have the same slopes. They're parallel. We just need to figure out exactly where they cross where this line crosses the y-axis. And you can see it's about here, but we want to be precise with that. So how do we do that? Well, we have enough information to solve it, because we know the slope and we know it passes through this point, 2, -1. If you have a point, 2, -1, that means that on this line, at some point, the solution to this equation is where x is equal to 2 and y is equal to -1. This is the idea of a linear relationship. And we can plug this in. So instead of y equals mx plus b, we have our y value. At some point, the y value equals -1. And when the y value is -1, the slope is -2/3. And the x value is 2. That's the value of the point. Plus b. We don't know what that b value is. So look what we have. We have an equation with one variable b. And that's what we're trying to find. Right? We're trying to find the y-intercept. So now we solve. 2 times -2/3 is -4/3. Plus b is equal to -1. I would add 4/3 to both sides. Right? This cancels out. And now what? Bring out a room where we can finish. B is equal to what? Well, it's -1 plus 4/3. -1, you can think of it as -3/3. And then plus 4/3. Not too difficult, because what you can think of is you have -3/3. That's 3 -1/3. And then you have 4 +1/3. That means that there's just 1/3 left over. Or you could just add a -3 and 4 to get 1. And that's 1/3. So this gives us our equation of our line. Y is equal to what? Well, our slope is -2/3 x times x. That's our slope, -2/3. And then there's an x value. Just to be clear, I think I might have said it a little funny, but -2/3 is the slope, right? And not -2/3 x. And then we add 1/3. That's the y-intercept, and there's our equation. If they want the coordinates of point C, what would that be? We can see it. It's right here. It's on the y-axis. So the first part of the point is 0, and then this number is the second part. It's 1/3. So the coordinates are 0, 1/3, and it crosses the y-axis at 0, 1/3. So the idea is that you can use a point and a slope to find the equation of any line through this process. All right, thanks.